So in this video, I'm going to explain the next logical instruction, which is called as a ORA. So the meaning of this instruction is logically or with accumulator. So here, the purpose of this instruction is this instruction will perform the logical ORing operation with the content of accumulator and the specified operand. That operand might be 8-bit register or memory content. So here the opcode for this instruction will be what? The opcode for this instruction is ORA, and their operand will be either 8-bit register or it will be memory. So we can understand this instruction with much of clarity with the example here. So let's say, for example, if I am writing here ORA with the operand as a C register, and here let's assume before execution of this instruction, the data I am taking here, so that this accumulator content is as a 03H, and this C register content I am assuming here as a 81H. So now how the operation will perform here? So this A is having 03H and this C register is having 81H. So here their binary pattern will be, for 0 it will be 4 times 0, for 3 it will be 0011, and for 81 we can write it here 1000, and for this 1 we can write it here 0001. So now how will be their operation here? So as per the logical OR operation, what I had explained in the previous video, that if any input is 1, then their output will be 1. So that might be that there will be both the input will be 1, or any one of the input will be 1, then their output will be 1. If both the inputs are 0, then as per the logical OR operation, their output will be 0 here. So from the very first stage, that 1 ORing with 1, it is here the output 1. Then from the second stage, 1 ORing with 0, logical ORing with 0 is giving the output here as a 1. From the third stage, both the input are 0, so their output will be 0. From the fourth stage, both the input are 0, so their output will be 0. Similarly, from the fifth stage, their output will be 0. From the sixth stage, 0. From the seventh stage, it is 0. From the eighth stage, that is 0. ORing with 1, their output will be 1 here. So their hex equivalent, it will be 8, and this will be here 3. So this result will be stored after execution of this instruction. This result will be stored into the accumulator itself. So this accumulator content will be 83H. Now we have to understand about their effect over the flags. So that as like for the previous instruction, whatever we had seen as a logical ANDing and logical XOR, in this logical OR also, sign 0 parity flag will be modified to reflect the result of the operation, and auxiliary carry and carry, as like previous instruction for the XOR instruction, here also for this auxiliary carry and carry, both the flags will be reset here irrespective of this result obtained. So here we can write this sign 0 parity, and this side it is auxiliary carry and this is here carry. So sign bit will be changing as per the result here. So this is the sign bit here 1. So here this MSB bit is 1, it means their sign bit will be 1 here. And this result is 83H, which is non-zero result. So that is the reason this 0 flag will be 0 here. And if you count that number of ones in this result, it is here 3. So 3 number of ones is called here odd numbers. So that is the reason this parity bit will be showing here as a 0. So this parity flag will be showing here 0, and irrespective of this result obtained here, auxiliary carry and carry will be 0 and 0 only. So this is the result, like this is the impact of this result over the flags to reflect this result here. So in the note we can note down here, in the note about the flags we can note down here that sign, 0, parity are modified to reflect the result of operation, to reflect the result of operation, but this auxiliary carry will be reset, and this carry will be also reset irrespective of the result obtained here, because whenever we are performing this logical operation here, then there is no chance to generate the extra bit from the fourth stage as auxiliary carry, and there is no way to generate the extra bit from this eighth stage from this carry position. So due to that reason, this carry and auxiliary carry cannot be generated from this logical ORing operation. So due to that reason, as per their design aspect it has taken, auxiliary carry will be reset and carry bit will be also reset here. So these things you must have to keep it in mind while studying about this instruction or while applying about this instruction into the programming part. So now we'll talk about their size, machine cycle and T states. So here if you see that ORAC, so this instruction consists of only English alphabet. So as per that logic here, their size in terms of byte, it will be only 1 byte. And here with respect to machine cycle, this is having by default only opcode fetch operation, because the component involved in this operation will be accumulator, which is inside the processor itself. Then the second operand as a C register, which is also inside the processor itself. And to perform this logical operation, ALU unit, that is called arithmetic logical unit, where this operation performed is also inside the processor. So outside the processor it is going to take that only opcode from the memory chip. So that is the reason it is accessing this memory chip only once. So due to that reason their machine cycle is referred here only as a one machine cycle. And as we know that by default for the opcode fetch operation, the number of T states required for this opcode fetch operation is 4 T states. So for this instruction it will take only 4 T states. So the number of T states will be 4 here. Now if the operand is memory, how the things will change? So for example, let's say if I am writing here ORAM, as like previously for the XOR operation, for the AND operation also we had taken that memory as one of the operand. So how the things were happening there, with the similar fashion here also the things will happen. So here the operation of this instruction will be, it will perform logical ORing operation with the content of accumulator and with the content of memory location whose address is pointed by the HL register pair. So let's say if this HL register pair is having the content as a 2000H, it means from this memory whatever is the content at this location 2000H. So let's say here we have the data as a 81H. It means this will be pointed by this HL register pair. HL register pair, before execution of this instruction, whatever is the content of HL register pair, so that will become the address of that data in this memory organization. So in this memory organization, wherever it is 2000H, so that will be pointed by this HL register pair content, and that at that place what is the data here as a 81H. So this 81H data, it will be copying or it will be transferring from memory to processor, and then inside the processor that accumulator content and this 81H is going to be performed this OR operation, and after the operation result will be stored into the accumulator itself without making any change in the data at this location. So even after execution of this instruction, if you check it here, the data at 2000H, then you will find out the same as a 81H. It is just copying. It is not cutting the data here. It is just copying. So copying means 81H data will be copying from memory to processor. So that operation is called as a memory read operation. So now if we talk about this size, so here also in this instruction also, like this instruction consists only English alphabet. So with respect to size, it will take here only 1 byte. And with respect to machine cycle, by default for any instruction, first operation will be opcode fetch. So the first operation will be opcode fetch. During the opcode fetch, whenever this processor is decoding and executing this instruction part, then by that time it is knowing that their second operand is outside of the processor. It means it is from the memory. So to read that second data from the memory, it is required further one more machine cycle. So that is called here as a memory read. So total number of machine cycle to execute this instruction will be 2 machine cycle, and as we know that by default for the opcode fetch it will take 4 T state, for the memory read it will take 3 T state. So total number of T states will be here 4 plus 3 is equal to 7 T states. And over the flags, how the things is changed for this ORAC, with the similar fashion for this instruction also, that flags will be going to be modified as like sign 0 parity flag are going to be modified as per the result obtained, and auxiliary carry and carry will be always reset after execution of this ORA M instruction, irrespective of the result obtained after this ORing operation. So I hope you understand this instruction with much of clarity. Thank you.